So let's talk about switch, right? Let's do that. Okay. Okay. So let's say this is a switch. Switch, right? Switch one. When, let's say there is a PC1, wants to talk to PC2. Right? So PC1 wants to talk to PC2. PC1 is connected to switch on, let's say port 1. PC2 is connected to the switch 1 on, let's say on port 5. And there is another PC on port 3. Let's say that is a printer. And let's say there is something on port 4, which is like a server, like a copy server to copy the names and all of that, right? Let's say that. So PC1 is connected to the switch port 1. PC2 is connected to switch port 5. A server is connected to switch port 4. And a printer is connected to switch port 2. So these are all different ports that are connected to the different devices, right? So let's say the PC1 wants to talk to PC2. What does PC1 mean talking to PC2? What does that mean is like maybe like sending an email or sending a file or sharing the content, something like that, right? So it could be anything. So let's start with that. So PC1 wants to talk to PC2, let's say to send a text file. So to make the network communicate between them, the PC1 does not know where the destination of the PC2 is. So what all I know is, I know the IP address of the PC2, right? So on the PC1 side, I know the IP address of the PC2. So let's say I wanted to make a network communication between them. To make a network communication between PC1 and PC2, there is a protocol called ping protocol. P-I-N-G, ping. Well, ping is not a protocol, sorry. I'm sorry there. Ping is just a name that is given. Let's call ping as a utility. I'm using a utility called ping to communicate between two devices to make sure the other device is up or not. Is it on the network? Is it replying to my messages? So I'm using PC1 to talk to PC2 using a ping to make sure whether the PC2 is on the network or not. Just to say, hey, hello PC2, are you in the network? If you are in the network, say hello back to me. So I'm using a ping as a utility to do that functionality. Then what is the protocol behind it? The protocol behind it is called ICMP. Anyone know the full form of ICMP? It's called Internet Control Message Protocol. Let's write it down. So it's called Internet Control Message Protocol. So basically, PC1 uses this protocol to talk to PC2. So what does this do? This protocol, what does this do is when PC1 wants to talk to PC2, it will send a request packet, which is called echo request. What it is expecting back is echo reply. So PC1 want to talk to PC2, it sends an echo request and it expects a echo reply back. So there is a code for the echo request. The code number is 0, and when it gets the response back, the code number is 8. It's not mandatory to remember the code number, but if you are interested to learn the bookish knowledge, just the code number is 0 for the request. ICMP request is 0, and the ICMP response is 8. So yeah, so PC1 will, you log into the PC1, you log into, you will do command prompt or terminal. On the terminal, you will type ping space. Let's give the IP addresses for these two. Let's say the IP address of the PC2 will be 10.10.10.10.2. And the IP address of the PC1 is 10.10.10.1. So now the PC1 with IP address of 10.10.10.1 wants to talk to 10.10.10.2. So what I'm going to do, I'm going to go to the control panel. I'm going to type CMD, go to the terminal, and I'm going to type PC ping 10.10.10.2. So when I did this command on the PC1 does not know what is 10.10.10.2. It does not know where to route that packet, right? So PC1 will look into a table called ARP table, ARP table. What is ARP? ARP, address resolution protocol. What is ARP? Because the PC1 does not know what is 10.10.10.2, it tries to look into the ARP table in its database. So PC1 will try to look in its ARP table to see, hey ARP table, do you know where is 10.10.10.2? It will check with the ARP table inside the PC1. The ARP table will say, I don't know. I don't know what is 10.10.10.2. So let me send that packet out of my PC because I don't know what is 10.10.10.2. Let me send it out. So that frame, this is called frame. What is frame? 0, 1, 1, 0. Those are called frames, right? Because everything is like zeros and ones. It's no longer 10.10.10.2. There will be counted to decimals and that will be sent out, right? So that frames will be sent to switch 1. The switch 1 will look into the source header. What is the source header again? So switch 1 will look into where the packet come from. It will identify that port as port 1. Okay, so I got a ping request. I got a frame from PC1 on port 1. So let me open my MAC address table. Let's see. Aruna, can you tell me what is a MAC address?
MAC address is the physical address assigned by a vendor for all physical devices.
Correct. So now switch 1 will identify that PC1 MAC address and it will store that on a CAM table. So what is CAM table? CAM table is a memory table that is used to store all the MAC addresses. So CAM table is like a memory table. So when the PC1 sends the first frame, the CAM table, I mean the full form of the CAM table, just for the, again, book purpose, content addressable memory. So the switch will store that in this table, that PC1 is MAC is stored in switch port CAM table port 1. So the switch is storing that, hey, I got a frame from PC1 and its MAC address is, let's say, let's give it a MAC address, AA. Let's give the MAC address of PC2 as BBs.
Hi Ravi, I'm sorry to interrupt, but if you're typing something, I don't know why, if it's only with me, but I'm not able to view that information on the whiteboard.
Oh, what do you see then on the whiteboard? You don't see anything?
I just see like the which is Drew, but not the information which you are typing from the keyboard.
Interesting. Okay. Is it same with everyone or?
Actually, we have to move the screen, means move the scroll button and see the location where you are typing.
It's not about the like where it's drawing, but I'm able to see everything, which is like PC1, PC2 switch and Mac cam, everything. But whatever he's typing from the keyboard, that information is not visible.
Oh.
Try to do one thing, Sai Sri. You can drop the call and rejoin back. Let's see if that fixes it. Let's try that.
It's not just today, Ravi. If it was from yesterday itself, but I thought it's the like something is problem from my system itself. But I'm facing the same issue today too. So I just want to check if everything is like normal to everyone.
Okay. Is it same thing for all of you guys, or do you see like what I wrote on the screen, like ARP addresses? Do you guys seeing that?
Yeah, we are able to see.
Yeah, I'm able to see it.
Okay.
Okay,
All
I
right
don't know
then.
what's wrong. I'm sorry. Then I'll drop again and I'll join back.
Okay, let's try that.
Yeah.
It's very weird. Okay, so we are talking about the content addressable memory, right? So the CAM table will store all the MAC address of the ports that it's coming from. So the PC1 send the first frame to the switch 1, and switch 1 know the MAC address of the PC1. It learned from port 1. But it's trying to reach 10.10.10.2. The switch 1 does not know what is 10.10.10.2 because it's a layer 2 device. It does not know what is an IP address, right? So what does the switch do now? Switch does not know what is the destination MAC address because the PC1, when send it out, it sent it as a broadcast packet. So PC1, when sending out, because it does not know what is 10.10.10.2, it will send that as a broadcast message. What does the broadcast message will have? The broadcast message will have who is 10.10.10.2. That will be the broadcast message saying that who is 10.10.10.2. Because it does not know the destination MAC address, it will put it as destination MAC as F, FF, FF, FF. So the PC1, because it does not know 10.10.10.2, it will put the destination MAC as all Fs, which is nothing but a broadcast message saying that who is 10.10.10.2. That frame got by the switch one will broadcast the message to all the ports because the destination MAC is all Fs. So this first frame came by the switch PC1, now received by switch one, it will be sending to printer on port 2, 5 on PC2, 4 on the server, except the port it received from. It will not send the packet back to PC1, that request packet, because the PC1 is what it sent from on the port 1. It will not be sent back to port 1 again because that is not the switch mechanism. So switch will broadcast except the port it learned from. It will send the broadcast message to all other ports. So in this case, the printer received it, PC2 received it, server received it, the broadcast frame. The printer will check who is 10.10.10.2. It will not reply back and discard because it is not 10.10.2. The server will receive it. It will not reply back because it is not 10.10.2. PC2 will receive it. It will check its IP address in its ARP table. It says, hey, I am 10.10.2. It sends the response back to switch one. Now the switch one sees that for this request MAC address, there is a response MAC address. So now it stores the MAC address of the BBBBB in its CAM table. So now the CAM table contains AAs on port 1, which is the echo request packet. It got the response back from BB on port 5. So now the CAM table has two contents. And the response packet will have the destination MAC address as AAAA. Saishri, I'm recording already. I just saw your message. Yeah, it's getting recorded.
Oh, I did that like long back. Sorry.
Oh, okay. Okay, no problem.
Yeah.
So the PC2 sends that to the switch one. Switch one will see that, okay, this message is supposed to go to PC1 because the MAC address of the destination is matching to AAA. It sent that packet to the PC1. So now the next request. So for this broadcast message, it got a response saying that PC2 is 10.10.10.2 and PC2 MAC is MAC address is BB, like that. So now the PC1 know that the MAC address of the PC2 because the switch told PC1 that it got a response from 10.10.10.2 that's on the port 5. It's stored in the CAM table, and the switch one will send that back to PC1 responding that, hey, it's BBBB. So now this 10.10.10.2 is stored in ARP table. So now PC1 will know 10.10.10.2 is mapped to BB, BB, BB. So next frame, PC1, if they want to talk to PC2, it does not have to broadcast because it already know 10.10.10.2 is BBBB. it will look into its own ARP table. So the next frame, the PC1 will look into its ARP table that it knows BBBB. So the destination MAC address will be BBBB. So that will be sent to switch 1. Hey, my destination is BBB. Send it to that. The switch will see its CAM table. Oh, BBB lives on port 5. So let me send that your request to port 5. So from the second packet, second frame, it will be a unicast. So the first frame will be broadcast because switch 1 doesn't know where to send the packet to. After the discovery is completed, from the second point, it will be a unicast packet, which will know where the destination lives. Are we clear on this?
What is the second packet? Unique?
Unicast.
Unicast. Okay, broadcast. Thank you.
Yeah, broadcast, unicast.
Okay.
Let's see. Harini or Harian, sorry. Can you tell me what is the difference between broadcast and unicast?
So broadcast is wherein you send the message, and the switch sends sends the packet to all the devices that are connected. Wherein in unicast you already know the address of the device, so you directly send it to that without broadcasting.
Correct. That is correct. Thank you. Saisri,
Yes.
what is the layer 2 to layer 3 mapping called?
Sorry, I missed that.
It's okay. Ritik,
So
what is the layer 2 to layer 3 mapping called?
that's what I want to ask you. So actually, I missed your the where from the Mac to CAM, the content addressable memory. So could you please explain from there once again, if you don't mind?
I will,
Yeah.
but let's complete my question. I'll come back to that answer again.
Sure.
Divya, can you tell me what is the layer 2 to layer 3 mapping called?
Address resolution protocol, that is the process like where we map layer 2 to layer 3.
Correct. Thank you. Perfect. Rajesh, can you tell me where do switch stores all of its MAC addresses?
Sorry,
Where
where
do
do?
switch store all of its MAC addresses?
In a table, what you say? Hello.
What table? It's okay, Rajesh. We need a little bit more attention on this. Let's go to Lakshmi.
Is it a CAM table?
CAM table. Yeah.
Yes, correct. CAM table. Thank you. Aruna, what is ICMP request 0 called?
Zero is echo request. Echo request 0 means sending a ping command to see where the device is.
Correct. Thank you. Okay. I think we covered pretty much about this topic. This topic is very important because every day we have to know how do the switch sends the packets or frames. Otherwise, it's tough to troubleshoot. You get tickets saying that, hey, I am in PC1. I'm not able to talk to PC2. They will give you IP addresses and you have to figure it out why they are not communicating. Then what you will do is you will log into the switch. You will check the MAC address table to see where the source PC, what is the destination PC, and you will troubleshoot why they are not able to communicate. Are you learning the MAC address or not on the MAC address table? If not, then we will go into deeper on VLANs, trunking, and all of that in the future. But this concept is like a very fundamental topic to understand your switching right. Layer 2 depends on this topic only. If you understand how the switch broadcasts and how it makes a unicast, how it stores that in the CAM table, how does it map with the ARP table, I think you are making your baby steps into networking. So try to repetitively go through this process. I know it's not easy to understand or make it or break it on the one go, but try to repeat this process again and again, because it's very important to troubleshoot on every day. So that's that. There is that. And let's move on. I know I'm running very late on the time. I wanted to cover a lot of topics, but I couldn't. But it is what it is. Okay. Let's talk about VLAN. There is PC2, PC3, PC4, PC5, and there is PC1. So let's say PC2 is owned by marketing user, PC3 is used by marketing user, PC4 is used by HR, PC5 is used by accounting, and you are admin. So you want to send a message to HR. So your IP is 10.10.10.1. This is 10.10.10.2. This is 10.10.10.3. Maybe this is 4. This is 5. Right? For a namesake, let's talk about those IPs, right? So the admin want to talk to HR. So initially, the admin does not know what is the IP of the HR. So admin sends the packet to the switch. Switch is going to broadcast to all the PCs. And HR tells that, hey, I am the one you are looking for. And in the packet. So admin want to talk to HR. They want to send in email regarding all of the payrolls of the users. All the pays, how much they are earning, everything have to be communicated between the admin user and the HR user, right? In this case, if they all part of one broadcast domain, there is a chance that someone in the same switch can put a different PC in the same domain, and they can listen on this communication. There is no separation of this department versus this department. That means that they can put one more machine in, one more marketing user can connect to this switch. They can listen on that port because the switch is broadcasting to all the ports initially and see who responds back. So to avoid that, we are separating the broadcast domain into multiple smaller domains to separate one department over the other. So VLAN is virtual local area network. You guys know LAN. LAN is nothing but connecting of multiple devices, but you're making it as virtual, meaning like you're separating one LAN into multiple logical separations using VLAN. What does this VLAN do is, on the switch port, when you build the user, you will attach that to, let's say, admin user 1. You will make this port as, let's say, VLAN 10. Similarly, you have 4, right? You will put this also in the VLAN 10, but you will put this port in VLAN 20, and you will put this port in VLAN 20. So this time, when the first frame comes, instead of broadcasting to everywhere, to all the ports, it will broadcast only to the VLAN 10 ports. So your first message, the broadcast message, because it received on VLAN 10, it will be sent to only ports which are on the VLAN 10. So we are separating the broadcast domain into multiple smaller domains. So when someone asks you, tell me what is a VLAN, you can tell a VLAN is nothing but separating a local area network into multiple smaller domains, or separating a broadcast domain into multiple smaller domains is called a VLAN. Any questions there?
Can you please repeat VLAN again?
Okay, so let's say there is a switch. PC1 to talk to let's say there is a small store. That small store has user 1, which is working as a sales user. And there are other sales users, sales user 1, sales user 2, sales user 3, and sales user 4. There are 4 sales users, right? We want to make sure the sales user 1 cannot talk to sales user 3 and sales user 4. They can talk to only sales user 1 or 2. So to separate their networks, to separate their communication, we put 3 and 4 users in different VLAN, 1, 2, and this user in different VLAN. So when a frame is received on the switch, instead of broadcasting to all other ports, it will broadcast to the ports which are part of that specific VLAN. That is called VLAN. Okay, earlier someone asked about repeating about the CAM memory. So let's go back there. I totally forgot about that. So MAC address is the hard-coded address that is given to a physical machine. A switch will store all of its MAC addresses in the CAM table. So if you see, there will be a table that will have 3 columns. One is port number, and the other one is MAC address, and the other one is time, at what time it learned the MAC address and what is the age of the MAC address. So this is how a CAM table look like. So the switch will learn the information coming from the PC1. The switch will learn the information coming from the PC1, and it stores the PC1 MAC address in this MAC address table with what port number and what time it learned and what is the age of that MAC address. Is it like 5 minutes? Like that. When the switch PC2 is responding back to switch 1, it will add the PC2 MAC address in its table. So on its table, it will identify, okay, it's running from port 5, MAC address is BBBB, and what time it learned from. So the MAC address is to identify the device. The CAM table is the table that stores all the MAC addresses on the switch. Is that clear?
Yes, sir. Thank you.
Okay. Is that clear about the VLAN?
Yes, thank you.
Actually, originally the connection is in the LAN and we are segregating the connections. That is called VLAN, right?
Yes, we are separating them into multiple smaller domains. That is called a VLAN, correct?
VLAN. Okay. Oh, thank you.
So let's say, let's do a troubleshooting scenario. So there is a switch. Let's say you guys are working in a company, let's say Capital One. You are given a job and you got a ticket saying that, hey, my PC1 or let's say my application server, which is IP address is 10.10.10.1, is not able to talk to 10.10.10.2. So you know the topology. I mean, you know how they're connected. So there is a physical cable running from application server talking to the web server. A customer says that he opens a ticket. You guys use ServiceNow or something, a portal to create the tickets. You got a ticket saying that the application server is not able to talk to web server. So you are the administrator now. So how are you gonna troubleshoot this problem? Let's pick Lakshmi. You were given this ticket. How will you solve this problem? I mean, what do you check first? Let's talk about that.
Physical layer.
Okay, you check the physical layer, and the physical layer light is good here. The physical layer light is good here. Okay, next what?
Data link.
Okay, in that, what are you gonna check in the data link?
Whether that IP 10.10.1 is going to switch or not, responding to the switch or not. That PC1, which is sending from PC1 to switch, is it sending the data or not to the switch?
Yes, it is not able to send the data. That is the problem. Correct. Any ideas?
No, actually, I didn't attend first class. I just went through that recording half only. So I have to go through that recording again.
It's okay. You tried your best. Thank you. We'll move on. Shruti, any ideas?
Oh no, I have no idea.
Okay, Rajesh, any ideas? Divya, any idea?
We can check this switch configuration, like if this switch is configured correctly with no errors.
Okay, what are we gonna check? So you log into a switch. What do you look into it?
Like if it is throwing any error message or warnings.
No errors, no warnings. But what? Yeah, I think you're in the right path here. Let me give you some hint so that we can move along.
Yeah,
So on
can
the
you
switch,
please
when you
repeat the
log in,
question one more time?
okay, so there is an application server that is connected to switch on this port, and there's another web server which is connected to this port. They both are not able to communicate, meaning like they cannot ping, they cannot send the files, they cannot talk to it. So as an administrator, our job is to fix their problem.
Okay.
So Divya said she will log into the switch. She will look into the errors of the ports. I mean, like she will do show logging and then she will check if there's any errors. But in this case, there is no errors. So what we should check is the CAM table on the switch. Is the switch learning the MAC address of the PC1 or not? Next thing to check is the switch learning the MAC address of the web server or not? So I'm gonna go to the switch and check the CAM table or the MAC address table, which are same, both are same, and see the switch is learning the MAC address of the source, in this case the app server, and the destination MAC address in the MAC table or not. Let's say the switch sees both of them. What is the next step we have to check? Let's move it on to Ritik. Now we know the MAC addresses are learning on the switch, but still they are not able to communicate. Do you know any ideas?
Matching of ports.
I'm sorry, matching of
ports.
Whoa, not following. Matching of ports, what do you mean?
Like we need to send from the app server to web server. They should be on the same port to transfer the data, right?
Oh, okay. I thought you're talking about the TCP port. Okay, we are not there yet. The communication at the network layer data link layer is not there. I think you went up to the TCP layer, but before that, we have to make sure the data link layer works, right? In this case, the ping is not working. Okay, but good thought. I think you are looking into the data port, whether it's, they have to listen on the port, they have to get communicated. Yeah, that's one step above, but we are not there yet. Let's move on to Monica. Monica, any ideas?
We can connect two devices by passing ones and zeros.
No, we check the MAC address, right? So the switch, meaning like the PC1 sent the first frame, the switch got it.
Okay.
But the switch cannot send it to the web server. What might be the problem?
Maybe the host is down or it didn't get the echo reply.
If the host is down, why it will learn the MAC address?
Yeah. Okay.
Let's open it up. Anyone? Any ideas?
Network layer connection.
PC2 doesn't have an MAC address in the CAM
No,
table.
it has it. It has it. It has it. The MAC address is there.
I might be wrong. Maybe the port is not listening.
No, that the port is not listening. Same thing the other guy said. That is something at the TCP layer. We are not there yet. I think I'll give it to you guys. It's okay. They both are not in the same VLAN.
Okay.
Aha. Okay, so the PC1 is in VLAN 10 and PC2, the web server is in VLAN 20. So even though it sees in the MAC table, the PC is not sending that frame to PC2 because it's in a different VLAN.
Okay. So where the VLAN addresses will be stored?
It will be attached on the port. We attach that on the switch port. It's a manual configuration. We type switch port access VLAN 10 and switch port access VLAN 20. It's a manual configuration that's done on the port.
So if we check on CAM table, so we can't see that like a port number by knowing the port numbers. Like once PC1 sends, that means here in the CAM table it stores port 1 has sent it, and the MAC address is 10 dot some MAC address BA or something. PC1 MAC address is, and PC2 if it is responding or if it is not responding back. So it stores in the CAM table, right? So we can't know that it is not in the same VLAN.
Using the CAM table, you will know it's in the same VLAN or not, but you can also check on the running configuration on the port. When you do show run interface port 1, you will see what VLAN it is.
Okay.
Or you can do show VLAN ID and then define the VLAN number that will show you what ports that are part of that VLAN.
Okay.
So I think we are not there yet. I think we are not there yet. I think we have to log into the switch, show the configuration to see how to troubleshoot with the commands, right? I think we are not there yet, guys. I know the enthusiasm is higher here, but to see that, we just need to have a little bit more patience. That's what I'm saying. You guys can install the packet tracer and you can install, you can put the switch there and you can check those commands. But to answer, I think what is your question exactly, Lakshmi? Are you trying to ask a question or saying a statement there?
Actually, my question is here, when we check on CAM table, right? So if the response is not coming back, that's what you ask, right? So here, when we check on CAM table, the port number and the MAC address, when we check, so if it is responding, then we can see here only, right? We come to know that those two are in same VLAN table when we check on the CAM table, right? That's what my question.
Well, so let's talk about that, right? So on the switch, this is VLAN 10, this is VLAN 20. So you're saying when the responder is not responding back, how does the switch know its MAC address? Is that your question?
Yes.
Yeah, I think the question is like if they are on both different VLANs, how come the CAM table has both MAC addresses?
Yes,
Exactly. But remember, guys, this is not the only host on this switch. There might be other hosts in the same VLAN trying to talk between them. So let's say there is another printer trying to talk to this web server. That might be the reason why switch know the response packet of this server. Switch will know one way or the other the MAC address of all the ports it's connected to, right? But in a dead switch, meaning like the first packet, this is like VLAN 10, this is like VLAN 20, and this is also VLAN 20, and this is also VLAN 10. So let's say this PC want to talk to this PC. So now the switch will know the MAC address of this port and the MAC address of this port. So switch already know. But if this PC want to talk to this PC, will it be able to do?
No.
Why? Because they are part of two different VLANs.
Yes.
So even though the switch know because of this communication, that doesn't mean these two can communicate.
So actually, like the switch knows from where the message is coming and from where it should send. Like, why can't it send directly? Either like if they are on different VLANs, like why is it stopping? Like what is stopping switch to send data?
It is stopping because it will not send the data to any other ports which are tagged with that specific VLAN tag. The thing that is stopping is the VLAN header. When the switch receives the packet on the PC1, you manually tagged that with the VLAN tag value of 10. So now switch will not send that frame to all the ports. It will send only to the ports of VLAN 10 because of this header tag you attached. It will not send that to the VLAN 20 tag. So it is limiting that based on this tag value, which is called VLAN header tag. It's just like having a ticket to go to the movie. You have a ticket in your hand, you show it, you allow it. So you have the VLAN tag 10 here. It will be sending to all the ports which have that tag value only. The other tags which are having 20 will not be sent. That's a separation of whole point, right? If it sends to all the ports, then what's the point of having a VLAN tag in the first place? Right?
Yeah. Okay.
Okay.
So, but as you said before in the troubleshooting problem, it told that the switch is the cam table is showing the MAC address of the other, I mean the VLAN 20 also, right?
It will store it, but it will not send the data because it knows what VLAN tag it received from. So let's say, let's talk it one more time. Let's make it clear again. So the switch has VLAN 10 on this port, VLAN 20 on this port, and there is VLAN 20 on this port, and there is VLAN 10 on this port. Okay, so till now we are clear. So the now switch knows that port 1, port 2, port 3. I didn't understand that. Sorry. So port 4. So when the frame comes in, the switch, it will broadcast to the only ports which are on VLAN 10. So it's going to send that to only this port. It gets the response back because they are part of one VLAN. If there is no VLAN concept, if there is no VLAN on this port, then it will send to all the frames, all the ports, because there is no VLAN. But because we attached this VLAN tag, it will broadcast to only those ports. No, not clear?
Yes.
Can two devices communicate when they are in different VLAN? Answer me this. Can two devices communicate in a different VLAN?
No.
No.
What if we want to make them communicate between the VLANs?
The VLAN port should be same.
No. The ports are, the VLANs are separate now, but still I want to communicate in a different VLAN. How can I do that? So I separate them in different VLANs, right? So for example, there is HR team, there is marketing team. We separated them. So we make sure that they both cannot communicate between them. But what if I want to make them communicate without changing the VLAN numbers? What is the way?
Insert the VLAN header.
Now, the way to communicate is having a router. So then that's the next step. So the router can make two VLANs communicate. A switch cannot make it. That's why a layer 3 device router can make. If you remember our first introduction class, it's like maybe 2 weeks. I'm not sure you remember that or not. If they're in two different VLANs, to make them communicate, we need a layer 3 device which will connect two different networks. Two different VLANs can be communicated using a router if we need that. So let's talk that maybe in the next class. Let's focus on that. Let's repeat whatever we discussed today. So switch will, well, ping is the protocol that is used to communicate between two devices at a network layer. Ping works on ICMP. ICMP is nothing but inter-control message protocol. ICMP uses echo request, echo reply to send the request and response back. And the table that converts the IP addresses to MAC addresses is called ARP table, address resolution protocol table, that will match the IP address to the MAC address. The switch will store the MAC addresses in a table called CAM table, which is called content addressable memory table, it will store all of its MAC addresses to it. So when there is no concept of VLAN, when a frame is received on the switch will broadcast that packet, meaning like, who is this destination? Can you respond back? It will send that to all of the destinations. If someone responded back, it will store that response in its CAM table. From there, the switch will do unicast, one-to-one messaging. Now we wanted to separate them, not to use the broadcast. We wanted to separate the broadcast domain into multiple smaller domains. Then the concept called VLAN, which is virtual local area network, that came. We are separating one broadcast domain into multiple smaller domains, meaning we are putting one port in one VLAN and the responding device also in the same VLAN, then they both can communicate. If they're in different VLANs, the broadcast message will never go. The switch will never make them talk because they are part of different VLANs. The reason is the VLAN header value has to match in the response, otherwise it will not send that packet to the ports which are in a different VLAN. There is a concept called trunk. I'm not going to confuse you today, but we will talk about that more when we talk about routing and how we wanted to make two VLANs communicate. That will be the next class. I think because of the curiosity for tomorrow, let's see about logging into a switch, how to do the show MAC address table. Let's look into the real time. How does this look? Maybe to get more clarity, we'll do that tomorrow. But I think we are running very behind the schedule. So maybe we need to add one more week to the training. I don't know what we're going to do, how we're going to adjust that, or we have to do more. But I don't want to overfill the bottle, right? There will be a bottleneck. If I put too much on one day, I'm sure it get lost. I don't want to lose the information. Even if I teach one topic, I want to make sure it gets it right and it stays there for longer time. I don't want to put more stuff into one day because just to complete the course. So we'll see how we can accommodate that. Anyways, let me stop the recording and we'll open it for questions.